Alright, welcome back. In this video, we're going to be talking about the filling bottle problem, which is the type of problem that is not explicitly mentioned in the AP Pre-Cal course description, but if, your Pre-Cal teacher's looking in an AP classroom, seeing a couple of multiple choice items that are dealing with this stuff. So I want to prepare you for this type of question. And the concept here is that we've got a bottle, and it's getting filled with liquid at a constant rate. And the bottle's sides are changing somehow, and what's going to be what's going to be the graph of depth versus time. Okay, so I'm gonna try to keep this as simple as possible. Really, what matters is the width of the bottle and how that's changing. Okay, and it makes sense, fits in with our discussion of rates of change and such. So I'm gonna try to keep the colors consistent with what I'm gonna do on the homework video, which honestly I've already recorded. So I'll be using blue to indicate, areas where the width of the bottle is staying constant, red to indicate places where the bottle is getting narrower, and green to indicate where it's getting wider. So with this first one, I'm going to say, all right, we've got constant width through here. Okay. And then it gets narrower, and then it's a constant width again, but it is a narrower constant width. All right, so envision the water, going in with a hose or something where we've got it, turned to a certain level and the water is flowing in at a constant rate. Okay. When it's wide, compared to when it's narrow, it'll be great. The water level will be going up slower, right? Because there's more space to fill up. So, but if it's filling at a constant rate, the depth would be going up, with a constant rate of change, like a line segment. And that's going to be important. That when the width is constant, we've got a line segment. In fact, let me make sure this snaps to and makes a line segment here. There we go. And there we go. It's straight now. All right, but then the bottle gets narrower. And so I want you to think about how the speed of the height is going to be changing. Is it going to be speeding up, or is it going to be slowing down as a result of the bottle getting narrower? If the bottle's getting narrower, the height is going to rise faster. Okay, because there's less width to fill up at each level. It's a bit of a calculus perspective, but so as the graph of depth versus time is speeding up, that means that the graph is going to be increasing at an increasing rate, and it's going to be concave up. Okay, so I'm going to be drawing a concave up curve, and I'm going to have to take off the snap too. It's going to be going at that same rate at first, but it's going to be kind of going up a little bit. Okay. But then I'm actually going to draw that a little differently. Just a little bit of concave upness. That's not quite enough. Hold on. All right. Kind of realized I'd boxed myself in with the slope of that line. It was the curve was getting a little too vertical. Okay, but then at the end it goes back to constant. So I'll have another line segment, but this this width is much narrower than the original width, so the height will be rising faster through the neck of the bottle than it was at the base. And so it will be a line segment, but it will be a steeper line segment. But that should make sense because the slope got steeper. Let's see, yeah, great. The slope got steeper on that interval in red when the graph of depth versus time was concave up. Okay, so that's going to be my sketch of depth versus time. And then the other thing is, if I was going to try to make this perfect, I would try to make the width of the blue and red intervals about proportional to how long it took. But we're not going to worry about that, right? It just should be straight, concave up, and then straight again, but a little bit steeper than the first straightness. All right, let's move on to a different bottle. All right, so this is an interesting looking bottle here. And it's curved. And I'm really not going to worry about the difference between it being curved and, if it was, that kind of bottle, okay, with very straight edges. I'm not going to really get into the differences there. I don't think that matters because we're just gearing up for a potential multiple choice question, right? And you're not going to ever have to sketch the graph of the bottle on the test or on the AP exam. That would be crazy and impossible to grade. So first, it looks like as we go up, the bottle's getting narrower. And then it gets wider again. So I'm going to say, all right, narrower through here until I get to that minimum width. But then it goes wider after that. All right, earlier we drew a graph, and where it was red, the graph was concave up, and that's going to keep being the same thing. When the bottle itself is getting narrower, that means the graph of depth versus time is going to be concave up because the height is increasing at an increasing rate. It's speeding up, so to speak. So I'm just going to draw that. I'm going to say, all right, it's concave up about like that until about halfway, and then it starts, the opposite happens. It starts getting wider, so it takes longer to fill up each little section of bottle, with a small height, because those things are having more volume and it takes longer to fill it up. So the graph is going to become concave down, and so I'm going to draw that in teal. And the height, it'll still increase, but at a rate that's slowing down a little bit. And my face was partially blocking it, but there you go. It's about the same amount of time spent concave up as concave down, which is the same as, the height of the bottle. And the time it's getting narrower is about same amount of time as or amount of height as it takes for it to get back to the same amount of width. All right, let's go to another bottle. All right, so this one kind of looks like a funnel. So it starts off constant and pretty narrow. So when it's narrow, not very wide, the water level is going to go up pretty fast. Okay? But then it gets wider. So that height increase, it's slowing down as the bottle gets wider. So I'm going to start off in constant. That'll make a line segment. It'll be pretty steep though because the bottle is relatively narrow. So I'm going to draw it about like that. And then it's going to pick up and it's going to be concave down. So it's going to continue increasing but leveling off. So I'm going to get my teal pen and kind of continue on this pattern with a concave down shape. Okay, and that'll be a perfectly fine graph of depth versus time. And so, there's practice on the homework, and then I've got some practice problems in addition to this that you can do to, help prepare you for different bottles. You could also just kind of make up your own bottles and then start sketching depth versus time if you felt like you needed more practice. If you needed more practice and you were feeling aimless, just contact me and I'll draw you some bottles and have you sketch the graph of depth versus time and work with you on it like that. But we also need to be able to do the opposite. We need to be able to look at a depth versus time graph and conclude what type of bottle would get us there. Right, so we've got depth versus time and given, draw the bottle. And this is going to be hard, right? Especially if you're like me and not the best artist in the world. If you're really good at drawing, then you're going to have a great time with this, I bet. But I think it'll be all right. What I'm going to do is I'm going to just kind of use the same color scheme. I'm seeing a line segment here, so I know that the bottle has to have a constant width through here. Okay? But then I see another line segment right after. So I know that the bottle also is going to be having a constant width there. It's just that, okay, it's rising faster than it was at first. Okay, so at first it was rising slower, so that means it was wider. So the corresponding bottle will be wider. And I kind of always assume that these bottles are round, but I don't know that that's necessarily got to be the case. They just got to be the same shape all the way through. Prism of some sort. All right, so it's got a constant width for a while, but then it's going to have another constant width, and that width will be narrower because the water level's, rising faster. So I drew one of these for the homework, so I got a little bit of experience. Saying it's going to be like this. Suddenly, the height of the bottle got much narrower. And I know it's sudden because of that sharp edge right there. So there we go. Put the top in, and it kind of looks like a juicer or whatever, the type of thing you stuff stuff in the top and it grinds it all up or whatever. Okay. For this one, okay, we are concave up the whole time. And this is where I'm trying to make the connection back to what we were doing earlier. So I'm going to scroll back. These graphs we made. And notice that always in red, we were seeing concave up. And red corresponded to places where the bottle was getting narrower, right? That's right there. Okay, so I know that when the graph is concave up, the bottle needs to be getting narrower. This is concave up the whole time. So I'm just going to draw, and I was supposed to mention, okay, that, to do the same thing to the bottle that I did before, is that the blue is for having a constant width, and then, well, it's another constant width, it's just a different width, and it's narrower, so that causes the graph to rise faster. Okay, over here, this thing is concave up, right? It's smiling. So that means that the bottle will be getting narrower. So, doesn't have to be anything super fancy, but, I'm just going to say it gets a little bit narrower. Maybe it looks like I think on the homework I said it's like a beaker in chemistry class. But I think those typically have some sort of like straight top. I'm sure that's got some sort of name, but that's going to be what it looks like. Because the graph is concave up, the bottle will be getting narrower as I go up. Okay, but then this one's got concave down and then concave up. Highlight that. Okay, so it's going to, let's say it becomes concave up about right there, about halfway through. And it's concave down before that. If we go back to our other graphs and just look, okay, where we see concave down is where the bottle was getting wider. So thinking about this graph that we're looking at, where it goes from concave down to concave up, that means the bottle will be getting wider and then narrower. Okay, first it's getting wider. Okay, so be like this, and then maybe it's getting narrower, like that. That looks like about the same. So getting wider, getting narrower. I don't want this bottle to tip over, so I'm going to give it some width down there at the bottom. But there's other ways that this could look, right? It might be round. It might be like kind of a circular bottle. That would be totally fine if that's how you saw it. But, again, concave down corresponding to where the bottle gets narrower, and concave up corresponding to where the bottle gets wider. I think I'm going to leave it at that. I think that'll be enough for this problem type. I'm 12 minutes in. I think that'll be enough at this point. Just practice, look at different examples that I've got set up for you on the homework, on the extra practice, the practical before the quiz, all that stuff. And if you're needing more, just consult with me. So that's going to be all for this video. Thanks for watching.